There's another way to solve a system of equations using your calculator that is super easy. The first time you do this, it may be confusing to you and it may seem like a lot of steps, but I promise you, if you do it 2 or 3 times, by the third time you'll say, oh gosh, that is so much easier. So I'm going to show you how to do that. This is chapter 5, section 4 homework. I'm just going to do number 1, number 2, and number 3. To do what I'm going to show you, your equations have to be in standard form. So that's when your x term, your x term, your y term are on one side of the equation, and then your constant is on the other. Keep your variables in alphabetical order. Your x has to come before the y. Remember that a and b are just coefficients. Those are numbers in front of x and y. But x has to come before y. So let's change this to be in standard form. How can you do that? Well, you need to get y over here with x. So we need to subtract y from both sides to get it on the same side as x. And then the second equation is already in standard form. So pull up your calculator. And we're going to use a matrix to solve this system here. Press second, matrix. Scroll over to edit and press enter. Here is where you need to enter the dimensions of your matrix. We have 2 rows because we have 2 equations and 1, 2, 3 columns. So this is a 2 by 3. The matrix will enter from left to right, and then it will come down to the next row. So you want to enter the coefficients of your matrix. So my coefficients are 1, -1, 1, 1, 2, and 13. So your matrix should look like this. So let's go ahead and enter that. Once you're finished entering your matrix, just take a second to look at your matrix and make sure you didn't enter in anything incorrectly. Once you're finished submitting your matrix, press second, quit, second, matrix again, scroll over to this math key here. And rather than scrolling down and searching for RREF, which stands for Reduced Row Echelon Form, we are going to press the alpha key and then this apps key. That's B for that's B as in boy. So alpha B, and it gives us Reduced Row Echelon Form. And it opens up parentheses, and it is waiting for you to enter your matrix A. And then press enter again. Here's your answer. The solution is this ordered pair here, where x is 5 and y is 4. So our solution is 5, 4. Let's do another one. Again, you want to put your equations in standard form. Make sure your x comes before your y, an equal sign, and then your constant. And as you can see, it's already done for us here, so that's great. So we can just go straight into entering our matrix. Second matrix, over to edit, Press enter. It's still a 2 by 3. And enter your coefficients. 1, -1, -1, 3, 2, -18. Just take a quick second to review your matrix. Make sure all of your signs are supposed to be negative are negative. All of the numbers that are supposed to be positive are positive. Second quit. Second matrix. Over to math. Alpha B. Second matrix. Enter, enter. So our solution is -4, -3. One last one. Make sure your equations are in standard form. X, Y equals a constant. X equal Y a constant. So this one's wrong. We got to fix this. We need to subtract 2y from both sides to bring it over to the left-hand side. So this is going to be 3x minus 2y is -15. Second matrix. Over to edit. It's still a 2 by 3. And enter in your coefficients 7, -6, -35, 3, -2, -15. Second quit. Second matrix. Over to math. Alpha B. Second matrix. Enter, enter. So our solution is -5, 0. Now let's do one last one from the other homework assignment, 5, 6, because these are a little bit bigger. See here, I have 3 variables and 3 equations. So here you want to, again, keep your variables in alphabetical order, but just make sure you write down the correct matrix. Here, what are my coefficients? 1, 1, 1, and 3. Here, which variable am I missing? I have x and I have z, but I'm missing y. So the coefficient for x is 1. I'm missing y, so we're going to put in 0 for y. And then my coefficient for z is a -1. And then my constant is 2. Look at the third equation. Which variable are we missing here? Z. So for x, my coefficient is 1. For y, my coefficient is 1. We're missing a z, and my constant is 1. So whenever you enter in your matrix, you're going to do all the same steps, but just you have to change your dimensions, and you have to make sure you enter in the correct matrix. Make sure you enter in your x, y, z's in order. If you're missing a variable, a 0 goes in that place. So this is a 3 by 4 because I have 3 rows, 4 columns. just going to look over this and double check to make sure I entered in everything correctly and press second quit, second matrix, over to math, alpha B, second matrix, enter, enter. So you can see X is 4, Y is -3, and Z is 2. And that's that. So there is something I want to share with you though. If you have noticed that here we have a diagonal of 1s, just like here we had a diagonal of 1s. This is called the identity matrix, and I'm not going to get into what reduced row echelon form is for this class. That's something that you would learn in calculus, but just know that you're always looking for this identity matrix here, where you have this row of this diagonal of 1s here. Now, if you do this RREF with your matrix and it comes up, your answer, your solution matrix comes up, and you're missing this identity matrix here where you have the diagonal of 1s, let's say on the bottom it looks really funky. It could be like 0, 0, 0, 1. If you do not have a diagonal of 1s and you're missing something here, but you have some numbers on the bottom. So let's say, for example, it looked like this. Here. Do you see here how I do not have the identity matrix here? I don't have a diagonal of 1s and then everything else is 0. This is just funky looking. This means you have two parallel lines, and if you have two parallel lines, they never intersect. And if they never intersect, then there is no solution. Now there's another case where there will be zeros all the way across the bottom. If your bottom row is all zeros, then that means you've actually drawn the same line. You would graph the line, and then when you graph the other line, you realize you're drawing the exact same line. An example of this would be 2x plus 3y equals 5, and then 6x plus 9y equals 15. Do you see here, all we did to get from this line to this line is we multiplied this line by 3. 2 times 3 is 6, 3 times 3 is 9, 5 times 3 is 15. So this is actually the same line. So if one line lies on top of the other line, then that means there are an infinite number of points where this line intersects, because every point that's on the first line is going to be on the second line. That means you have a dependent system and there are infinitely many solutions.